For millions of years, the changes in Earth's climate have been driven by forces of nature. But for the last century and a half, Earth's average temperature has been rising faster than any time in the past 10,000 years. The consensus in science is that much of that change has been driven by us.
We're on a track to 700 parts per million of carbon dioxide on the planet. We haven't seen that for 50 million years.
The signs are everywhere. Droughts in the American Southwest and Africa's Sahel, rising seas in Louisiana and Bangladesh, tropical diseases spreading north, and extremes of weather from Florida to France.
The climate is not what it used to be. It's not your grandfather's climate anymore.
This program is sponsored by the gas electric Prius with hybrid synergy drive. Now that's moving you forward.
Swiss Re is proud to sponsor Global Warming, the Signs and the Science, as part of its Sharing Solutions initiative towards a sustainable future.
You know, there are people who still say global warming needn't concern us. If it's happening at all, it's a natural trend, not much we can do about it. But there's now hard evidence which shows that the warming is not only real, it's accelerating. It's altering the climate's most basic elements, like rainfall and evaporation, days of sunshine and nighttime temperatures. Those changes are damaging the environment and agricultural production, threatening wild species with extinction, and putting at risk our lifestyles, our health, and some of our favorite cities by the sea. In the next hour, we'll follow the signs and see who, if anyone, is responsible. We'll meet scientists who are investigating new climate evidence, and we'll see what we can do to help. It all starts with the warming. But up here in the eastern Arctic, reports of heat waves and droughts seem far away. Inuit guide Ben Kovic is more concerned with the melting, the disappearance of sea ice and snowpack on a scale that's hard to grasp. Over the last 100 years, the world has seen a 1 degree Fahrenheit rise in its average temperature. But here and in Alaska, the average has climbed 4 to 7 degrees Fahrenheit in just 50 years.
The ice is forming a lot later than usual over the past few years, and it is breaking up a lot earlier. So that means the less ice there is, the less hunting that can be done by our people, and that means less country food. It means there's been a great shift in terms of the seasons and the changing of the environment in the Arctic here.
Earth's polar regions are signaling us that something unusual is happening. In the Antarctic, in January 2002, the Larsen B ice shelf broke up into small pieces. An area about the size of Rhode Island melted in less than a month. There is also melting in the world's mid-latitudes. These are NASA time-lapse pictures of Africa's Mount Kilimanjaro. Its snowcap is retreating year by year. And the famous Swiss Alps may one day have no more glaciers.
We are now at the actual melting front of the glacier. This glacier retreats actually at the rate of about 30 to 40 meters a year. This is about twice as much as the average retreating rate of the last 150 years.
But global warming isn't just melting the ice. It is triggering large-scale climate changes of every kind. The seasons have become unsettled. Atmospheric highs and lows are migrating to new regions, basically changing the way our daily weather works. But what are the causes, and why is all this happening now?
We know that climate is not controlled by just purely one thing, and in the case of the human control, it has resulted in changes to the chemistry of the atmosphere in the form of greenhouse gases and toxic metals, which are unparalleled in rate and also magnitude for the last many millions of years.
gases like water vapor, methane, and carbon dioxide. It's called the greenhouse effect. And for millions of years, it's kept Earth's climate livable. But why is the greenhouse starting to get too warm? The answer is that the sun, which warms the greenhouse, also fuels a process that cycles carbon from the atmosphere and stores it underground. Author Tom Hartman calls it current and ancient sunlight.
Through the majority of human history, we lived on current sunlight. Sunlight falls on the ground, stimulates plant growth. Plants trap that energy, the heat energy from the sunlight, through photosynthesis to form carbohydrates. And we would eat that, or we would eat animals that ate that. They eat current sunlight. And then, more or less largely about 1,000 years ago, in some parts of the world, we started using sunlight that had been trapped in the earth hundreds of thousands to millions of years ago, primarily coal. And that was the beginning of the use of ancient sunlight, sunlight that had been trapped by plants a long time ago and buried in the earth. Now we're liberating that carbon into the air as we burn this ancient sunlight, as we burn these fossils. And we're moving in the direction of returning the atmosphere toward the way it was before the dinosaurs.
The sources of carbon vary by region, but most researchers cite transportation for about 33%. Electric power generation in the U.S. produces about another third. While heating our homes, manufacturing, making cement, agriculture, and clearing forests account for the rest. The result is that the concentrations of CO2, which remain in the atmosphere for 100 years, have increased from 280 parts per million during the Industrial Revolution to 370 today, and it may climb to 500 within our lifetimes.
Now, carbon dioxide is very important because it's a greenhouse gas. Carbon dioxide is also physiologically important. It drives photosynthesis. It controls your blood chemistry. And you are saying we are going to change this by a factor of 2 and we don't expect any consequences? I don't need to understand the consequences in detail to be very concerned that there will be some.
Unfortunately, modern lifestyle demands energy. And without question, the United States is the biggest economy, the biggest energy consumer, and the biggest greenhouse gas emitter in the world. But that's today. By 2050, most economists predict China's economy will be larger than that of the U.S. More than 1 billion people are likely to want the same size appliances and automobiles you have. In Beijing, the Luos and the Ling family are buying the first cars their families have ever owned.
We're looking for cars more stylish. You know, I seldom drive. Most of the time she drives. So we're looking for...
Car ownership here has grown 500% since 1990.
Doesn't need to be really big, but it has to be cute.
By 2030, China will import as much oil as the U.S. But oil is only part of the problem. Coal-fired factories and power plants are the world's most often cited polluters. Like the U.S., China has huge coal reserves. And if their economy grows as projected at 10% a year, their contribution to global warming could be enormous. But why should the developing world cut back if we won't? And why should we cut back if they won't?
I don't think so. Any country have the right to ask others to do something, especially, you know, as you mentioned, the developed country, most of them emit more right now, and still emit more.
Another factor in climate change is global population increase. Though births in Europe and Japan may actually decline, the rest of the world's babies could push the population to 9.3 billion people by mid-century, 3 billion more than today. And a growing middle class will likely contribute solid middle class expectations.
So far, we have put out about 300 billion tons of carbon. At current rate, it will take us 50 years to do that again. If we keep growing like we did over the last century, by the end of the century, we will talk about 1,000, 2,000, 3,000 billion tons of carbon. So the scales have changed. In the past, so far what we have done is we tweaked the system. Now we are going to overwhelm the system.
Too many people and too much carbon pollution are already threatening is one of the world's leading authorities on urban heat threats. He says it's the sudden spikes in temperature, not the gradual warming, that take the most deadly toll in these close quarters.
If the climate variability increases, and if in fact, let's take New York, most of the summer days are still in the 80s, but now you have a larger percentage of days in the 90s and over 100, in my opinion, there is no doubt that heat-related mortality is going to increase. In every way imaginable, a northeastern U.S. type urban setting is probably the worst you could possibly imagine for heat-related mortality, and I might even add even worse than in most third-world cities.
Even without global warming, big cities run 3 to 5 degrees hotter than their surroundings.
I can see it in the air at certain times of the day when I'm riding. This haze of smoke on certain avenues where there's idling cars, traffic jams.
But add in global warming, and unhealthy air days could increase by 60%, according to a recent study.
I realize this mask doesn't stop everything, but keeps the soot and the gutter dust out of my face.
Bike messenger Paul Lamarca is not the only one fed up with the air that he breathes. In a landmark 2004 case, New York City and 8 states said enough and sued America's 5 largest electric utilities for immediate reductions in carbon dioxide. Opponents hammered the legal merits of the case, but New York State Attorney Peter Lehner says no one, including the defendants, denied that global warming isn't happening.
So here we have a situation where it would be terrific if the federal government were acting, and we believe that the science and the economics and the technology all demands a aggressive and strong federal reaction in response to global warming. But we don't control the federal government, so we take action where we can.
In Detroit, the fight for healthy air is being waged on a more local scale.
People of color and low-income people, usually because the majority of people who are low-income are people of color, are more affected by climate change and environmental impacts than other communities.
Nia Robinson is hoping to help these students understand the challenge, because in inner-city neighborhoods, bad air and heat waves have killed and will kill again.
When you start talking about the health effects of climate change, the toxic emitting facilities are usually located in the neighborhoods where these people live. So the problem is not only that their air quality is bad, it's that they're living right next door to power plants or incinerators or car factories or freeways. And we're walking through here wondering, oh God, it smells so bad, and these people have to live with it every day. When you grow up there and you live there, every day this is what you see. You start to believe that this belongs here with you. And so when your kids are sick, you don't necessarily equate that with this factory down the street. It's just, oh, my kids are sick, and so are the kids down the street.
I feel like, especially when it comes to depending on our generation to come along and really help and support the environmental movement, it's so hard because, you know, we have been quite the bling-bling generation, and all we care about are the Escalades and the clothes and the cars, and getting more and more and more. And like you said, it's hard to be given and taken. I don't think that as a whole we really want to give and take and say, well, I'll give up that house or that car for the environment. They don't care about that.
The reason that most humans aren't environmentalists is because they don't feel like they're part of the environment, and they are. They're an intricate part of the environment. And so I think that what's important is to get people to understand that you're a part of this cycle. You don't control it, you're a part of it. And what you do to harm it harms you.
While inner-city dwellers are more at risk than most, climate change is affecting people's health all over the world.
In the last 2.5 decades, we have seen the emergence of 30 diseases new to medicine.
Rising temperatures are expanding the range for infectious diseases like Ebola and Vibrio cholera. Alongside those diseases, excess CO2 is fertilizing the microorganisms which trigger allergies like hay fever and more deadly asthma.
One of the unexpected impacts of just carbon dioxide fertilization of plants with experiments of ragweed, which we CO2, we found that the growth went up 9 or 10%, while the pollen production went up 61%.
The impact of CO2 on plants and us is startling. But it's the climate's changes in precipitation patterns and the droughts which laid the groundwork for recent outbreaks of hantavirus and West Nile virus. In the summer of 2003, a human health disaster began to unfold in Greeley, Colorado. The first clues were dead birds, discovered in increasing numbers. Then horses started to die. Then people.
It was on TV every night, and to protect yourself and wear bug spray. But I hadn't even seen mosquitoes or been aware of them, so I didn't take any precautions.
We had a very moist spring, and then right after that, we had a very hot beginning of the summer. Set up perfect conditions for the mosquito breeding cycle to be shortened, set up the perfect storm for us.
With fully half the total American cases of West Nile virus, Greeley became a national story.
We certainly weren't expecting the number of cases, and the spectrum of disease has been quite broad, from individuals who have a little muscle ache, some joint pains, and a low-grade fever, to individuals who've had life-threatening encephalitis.
For me, it turned into meningitis. So, I had a brain infection, and I was disabled. It was difficult for me to walk. It's been very difficult for me to think, even now, which has been 2 months later.
Sharon's infection was high profile and deadly. But how many cases were not even reported?
For every one patient that we see who comes to our attention, there are at least 150 people who do not come to our attention. So we would extrapolate from that and say that here in the state of Colorado, we've had probably on the order of 200,000 individuals who've been infected with the West Nile virus.
While medical science is working on vaccines to cure West Nile, climate science is trying to forecast where the next outbreaks may occur. But understanding where our climate is heading is very difficult because it's such a complex system. 20 years ago, scientists didn't have sophisticated satellites or probes, nor the supercomputers to analyze mountains of data to make accurate projections. But now we're starting to decode some of the great mysteries of our climate. Its circulation patterns and pressure zones, the interplay between the atmosphere and the oceans. We're discovering how these systems work and why they're changing. Violent storms have been part of life long before human record-keeping began. But there's convincing new evidence that warming sea temperatures are intensifying these deadly events. For the last 2 decades, scientists have been probing the most powerful of these climate systems. It's called the El Niño Southern Oscillation, and it sets the pattern for much of the world's climate. Normally, the prevailing trade winds blow westward across the Pacific, pushing a current of warming equatorial water before them. As a result, the sea level is about 20 inches higher, and the sea temperature is about 14 degrees Fahrenheit warmer in the western Pacific than in the east. During El Niño periods, which used to occur every 5 to 7 years, the trade winds weaken, allowing the warm water to drift back towards South America. This reverse movement pulls major atmospheric systems along with it, changing weather patterns all around the world. In some places, it increases the rain. In others, it brings severe drought. But El Niños appear to be coming more frequently, and climate scientists are investigating whether global warming is stirring them up in unpredictable ways.
Well, El Niño is a heat transfer. It's Mother Nature moving heat, transporting heat from one place to the other. So if there's more heat in the global system, in other words, global warming, then it's likely that there'll be more tweaking of the dial, Mother Nature trying to balance the heat around the planet. So we may see stronger events, we may see more frequent storm events. We don't know that yet, but certainly the whole fabric of this Earth and this system is interconnected.
Mother Nature did more than tweak the dial in
see now is a little bit of reconstruction. What happened is that the ocean level in 1983 went up 55 centimeters for 2 months. No, this was not a tide, it was the sea level, 55 centimeters higher. Europe has 50 millimeters of rainfall a year in the average. You know, it's just 5 centimeters of rain in the average, including millions. In 1983, it rained 2,500 millimeters, 50 times more. In 3 months, it rained as much as 25 years altogether.
The village of Kalan was extremely vulnerable to this major kind of climate event. But it's not alone. Here along the Atlantic seaboard, rising sea levels threaten entire communities. The sea rise is being driven by melting coastal glaciers in the high polar regions and by the slow expansion of the warming oceans. Recent studies warn that all of New York's subways and tunnels could flood, and Miami's beachfront hotels could be hit by 15-foot-high storm surges. But in late August of 2005, the warning flags along the Gulf Coast were flying. New Orleans sat waiting well below sea level, protected by a levee.
Right now it's about 17 feet above lake level, and in Hurricane George, it got within about, I think, 2 to 3 feet of the top of the levee. So of course now we're all thinking about building levees a little bit higher.
It didn't work. The aftermath of Hurricanes Katrina and Rita has become America's most documented disaster. But the devastation of the Gulf Coast has been underway for decades. Before Katrina destroyed his lab, Shea Penland spoke with us from a Louisiana barrier island.
Just this last fall, we had 2 storms. Right where we're sitting right here now, the shoreline eroded 290 feet in a week. Since 1932, we've lost over 1,000 square miles of land.
In fact, the Mississippi Delta was losing the equivalent of 1 whole football field of dry land every 15 minutes. But just as frightening, southern Louisiana has the nation's only deepwater offshore oil port. This was Port Fourchon before Katrina, and this is now.
This one little place on Earth plays a strategic role in somewhere between 16 to 18% of this entire nation's hydrocarbon supply. And with coastal land loss on both sides impacting the highway, the vulnerability of our energy supply is increasing daily. We also have about 20,000 miles of pipelines in coastal Louisiana that were designed for being under the marsh and not for being in the Gulf of Mexico. So as the sea level rises and land subsides and the sea takes the land, those pipelines become exposed to a much harsher environment than they were designed for. And you just can't replace 20,000 miles of pipelines overnight. So it's a tremendous environmental situation that we're going to have to deal with in this next 20 to 50 years, starting now.
All of its fears were justified. Soon after Katrina and Rita, the infrastructure struggled at far below capacity, and U.S. gasoline prices soared to unprecedented heights. The climate patterns that may have contributed to recent Gulf Coast disasters have left far too little moisture in the American Southwest. The drought that started here in 1996 had, by 2004, killed off most of the pinon trees across 3 million acres.
Old-growth forests and woodlands here in the Southwest take at least 200 years to grow and develop. Yet a severe drought like this can cause those forests to die back in just a couple years. The bark beetle outbreaks can kill the trees in just a few weeks, and the severe fire events can consume a forest in just a few hours.
Scientists suspect the current drought may be part of a natural cycle, triggered by those fluctuating sea temperatures in the Pacific. Or could the changing climate be warning us that these trees may disappear from here forever?
Well, the key thing about climate change, and it relates especially to warming, diminishing the amount of snowpack that occurs in the mountains and on the plains. And so there's no soil moisture when you go into the summer months. It has a vicious feedback and tends to create conditions that are much more favorable for drought, and drought that is long-lasting and quite devastating. And those are the sorts of things we're likely to see as we move into the future with global warming.
In Delta, Colorado, that long-lasting drought has already arrived, and it's changing an entire way of life.
Last year, it was horrible. We had no rain. All the ponds, springs, most of them dried up. We were selling double the amount of cattle last year that we normally would in the summertime. This year, it's affected us the same way because these guys are trying to hold off. They don't want to buy feed and all the other.
Mark and Robbie LaValle run 400 head of cattle on a ranch that's been in Mark's family for over 100 years. She's an agricultural extension agent and attributes the region's troubles more to changing climate patterns than to the heat.
This is the 4th year of non-typical moisture. The total precip for the year still looks okay, but it's that timing of when the moisture came that is really altered what we see. And last year was severe, low snowpack, no rain whatsoever as far as spring rain, no monsoon rain in July or August. And so we saw a lot of things happen from the plant standpoint and just no water for irrigation. The other thing we've seen is there's been this whole infestation of other things. We've had cutworms and grasshoppers and all these other factors that have come into play. So it's been kind of this triple whammy.
Biggest thing got us last year was water. We had feed. We had to sell cows because we didn't have enough stock water to get us through, and we couldn't afford to haul. And we knew hay was going to be high. We did raise a pound of hay on this outfit. We kept thinking it's going to rain, do something, but it never did.
A lot of these guys I grew up with, the LaValles and Hotchkiss, most of that I spent a lot of my life up there. They're still young enough that they can get back in this thing.
Time's money now. 15 head, 900, bid a quarter. 900, not a bid now, quarter, not a bid now, quarter.
The ones that bothered me is the 55 to 70-year-olds that when they went out this year and last year on the drought, they probably will never come back.
It's not just livestock in Colorado that's under stress. The world's entire food supply may be vulnerable to climate change.
We expect climate change to aggravate current weather extremes.
Martin Perry headed the impacts report of the Intergovernmental Panel on Climate Change, which projected long-term changes in precipitation.
It will tend to make already dry areas, the arid and semi-arid tropics, drier because the amount of evaporation due to the higher temperatures will reduce water availability. For example, in this part of southeast England where I'm standing now, a 1 degree increase in temperature will generally reduce water availability by about 10%. We would need 10% more rainfall in an average year to make up for that 1 degree warming.
That same 1 degree of average warming would slash 10% off the world's rice yields, which provide a staggering 30% of Earth's food supply, raising grave concerns about the convergence of climate change and population increase.
So we're talking about 2.5 to 3 billion more mouths to feed on a world with limited amounts of good arable land and water. And so to achieve food security 40 to 50 years out, the amount of food we're going to have to produce is going to be at least 60% greater than the amount of food we're producing today.
So we're dealing with serious questions. The world's foremost food crop is at risk. Coastlines are eroding. Our western heartland is drying up. And human health is under threat. The more science we do, the more we understand how future climates might work. But some of those findings may bring unpleasant surprises. Could we be nearing some invisible tipping point where sudden changes in the climate stop civilization in its tracks? Or could Mother Nature turn on us? A case in point. It's widely assumed that forests store away much of our excess CO2 emissions, which help us breathe better. But investigators in the Rocky Mountains have unsettling evidence that an excess of fixed nitrogen coming in from the atmosphere may be upsetting all that.
We're studying nitrogen because it is part of the carbon dioxide story. You, me, plants, every other living thing on Earth is made is one of those, and in fact, it's an essential nutrient. Now, it's
basically like you or I, anybody else, the soil and everything that lives underneath there, plants and microbes, breathes. So as they breathe, just like us again, they're releasing carbon dioxide.
What the team is investigating is whether elevated levels of nitrogen in this soil are stimulating microbes into a feeding frenzy down in the old stored carbon.
So by adding nitrogen, the hypothesis is that we've given them more access to that food, more respiration, more carbon dioxide coming out of the soils.
If nitrogen is triggering the release of more stored carbon, where's that nitrogen coming from? Well, apparently it's coming from us. Every time we burn fossil fuels, we produce nitrogen. Every time we fertilize fields or manure piles up, we're spreading nitrogen around.
in Colorado. We have this very nice situation where we can actually pinpoint where our pollutants come from because there isn't very much out of here. Every night when cold air drains down from the bottom of the mountains, because you know cold air sinks, it sinks down to an area in the middle of the South Platte River Basin, about the town of Greeley, and it pools there. So all the air pollution that comes with it from Denver and from the agricultural fields pool down there, and every morning when the air rises, as it warms up, it comes back up the mountains. So it's coming from Greeley, from the lower part of the mountains, against the prevailing winds, because it's moving with hot air rising, moves up here to the tops of the mountains where you get summertime clouds. These summertime clouds condense, take all those pollutants, dump them down on the ground. And that's where we're getting the nitrogen.
If this nitrogen cycle